दोस्तों सॉल्यूशन क्या होता है? सॉल्यूशन होता है एक मिक्सचर, एक होमोजेनियस मिक्सचर ऑफ टू और मोर सब्सटेंसेस। होमोजेनियस मतलब कि फॉर एग्जाम्पल ये है नमक का पानी। अब अगर मैं आपको दिखाऊं तो आपको नमक दिखेगा नहीं। क्यों? क्योंकि नमक डिसॉल्व हो चुका है, उसके पार्टिकल्स पानी के पार्टिकल्स के बीच में आ गए, आप उसके क्रिस्टल्स नहीं देख सकते। दैट्स व्हाई इट्स कॉल्ड होमोजेनियस मिक्सचर। होमोजेनियस मीनिंग you can't see the difference between water and salt। and जब two substances हैं एक सॉल्यूशन में, उसमें होते हैं two components, एक solute एंड एक solvent। जो हम concentration टर्म्स का टॉपिक पढ़ेंगे उसमें हम फोकस करेंगे solute पे, लेकिन हम सिर्फ सॉल्यूट हम देखेंगे सॉल्यूट और सॉल्वेंट के बीच का रिलेशन। एंड ऐसा क्यों है? एंड ऐसा इसलिए है क्योंकि अगर मैं फॉर एग्जांपल मेरे पास है एक बॉटल, इसमें है कम पानी एज कंपेयर टू ये ग्लास। इस ग्लास में पानी थोड़ा ज्यादा है, एक्चुअली नहीं है, इसमें बॉटल से थोड़ा सा कम पानी है। नाउ अगर मैंने इसमें 1 टीस्पून शुगर डाला है एंड इसमें भी 1 टीस्पून शुगर डाला मैंने, तो आप बता सकते हो कौन सा मुझे मीठा लगेगा? आप बोलोगे दोनों, क्योंकि दोनों में शुगर है। हाँ वो सही बात है, लेकिन ज्यादा मीठा कौन सा होएगा? एंड आप मुझसे बोलोगे ग्लास में। क्यों? ग्लास में पानी कम है, सो उसमें शुगर का इफेक्ट ज्यादा है। दोनों में सेम अमाउंट ऑफ शुगर है, इसमें पानी ज्यादा है, जब शुगर डिसॉल्व होता है शुगर इवनली पानी के में स्प्रेड होता है। ये है मेन कहानी सॉल्यूशंस की। एंड कॉन्सेंट्रेशन यही होता है, कॉन्सेंट्रेशन होता है कि इतने अमाउंट ऑफ सॉल्यूट में, इतने अमाउंट ऑफ सॉल्यूशन में कितना सॉल्यूट है। अगर ज्यादा है तो कॉन्सेंट्रेशन ज्यादा होगा, एंड अगर उतने ही वॉल्यूम में सॉल्यूट कम है सो उसका कॉन्सेंट्रेशन कम होगा। वेल अलग तरीका है इसके। पहला तरीका कॉन्सेंट्रेशन ढूंढने का, आपने सॉल्यूट का मास लिया, you took the mass of solute divided by the mass of solution and times 100। ये क्या किया हमने सॉल्यूट का मास परसेंटेज निकाला। फॉर एग्जांपल अगर मैं मास केजी में है, मैंने निकाला कि 1 केजी सॉल्यूशन में कितना सॉल्यूट है। एक और तरीका ऐसा हो सकता है कि मैंने मास ऑफ सॉल्यूट लिया, राइट, इंस्टेड ऑफ मास मैंने वॉल्यूम ऑफ सॉल्यूशन से मल्टीप्लाई कर लिया, मैंने डिवाइड किया वॉल्यूम ऑफ सॉल्यूशन से इनटू 100। एंड यहां से आप तीसरा तरीका भी निकाल सकते हो कि मैंने वॉल्यूम ऑफ सॉल्यूट अपॉन वॉल्यूम ऑफ सॉल्यूशन। ये कुछ 3 तरीके हैं कॉन्सेंट्रेशन निकालने के लिए। रिस्पेक्टिवली इन्हें बोल सकते हैं वेट बाय वेट परसेंटेज, वेट मीनिंग मास, वेट बाय वेट परसेंटेज यानी कि दोनों के मासेस का रेशियो, इनका परसेंटेज, वेट बाय वॉल्यूम परसेंटेज विच इज मास बाय वॉल्यूम, एंड फाइनली वॉल्यूम बाय वॉल्यूम परसेंटेज, वॉल्यूम बाय वॉल्यूम। इसमें मोल कॉन्सेप्ट कहां से आएगा? ये देखो, मोलारिटी, सॉरी फोर्थ ऑप्शन है, मोलारिटी एक नया तरीका है कॉन्सेंट्रेशन निकालने के लिए। इसमें हम मोल्स ऑफ सॉल्यूट लेते हैं एंड वी डिवाइडेड बाय वॉल्यूम ऑफ सॉल्यूशन। we are basically trying to find how many moles of solute we have in 1 liter of solution। यानी कि मैंने अगर 1 लीटर पानी लिया है उसमें कितने मोल्स ऑफ सॉल्यूट है। अगर आप देख के इसका यूनिट बताओगे मुझे, यू विल से मोल पर लीटर, बिकॉज वॉल्यूम इज इन लीटर्स एंड मोल इज अ यूनिट, मोल पर लीटर। इससे हम एक और चीज बोलते हैं, मोल पर लीटर इज ऑल्सो इक्वल टू कैपिटल एम और मोलर। यानी कि if I have a solution, if I can say, if I have 1 mole of solute in 10 liters of solution, I have a 10-liter bottle of water and I have 1 mole of solute, I can say I have a 0.1 molar solution of that solute. The concentration is 0.1 molar or just moles per liter. I can express this in a different way. It's called molality. Molality has once again moles of solute upon mass of solvent. So this is completely different. Now, instead of volume, we have mass, and this is also of solvent, not of solution. Once again, this is in kgs. Now the unit matters. It has to be in kilograms. The unit for this is mole per kg or small m, which is molal. This is molar and this is molal. Keep that in mind. If it's a small m, it has to be molal, not molar. The next concentration term is mole fraction. Mole fraction, okay. Let me guess. It has to be moles of solute upon moles of solution. Yes, this is correct. But this is one formula, and there is another formula, not of this same thing. If I make some space, molality is denoted by a capital M, molality is denoted by a small m, mole fraction is denoted by chi. Chi is a Greek symbol, it looks like an X, it just has a longer leg. And this, we have found the chi of solute, meaning the mole fraction of solute. I can also calculate mole fraction of solvent, chi of solvent. What I have to do is just replace the moles of solute by moles of solvent, and moles of solution remains as it is. Now, mole fraction does not have a unit. It's just like mass by mass percentage or volume by volume percentage, because the unit of this is mole, unit of this is also mole, and so they cancel out. Okay, we have 3 more. The next concentration term is strength. This strength has not much to do with moles. Strength is just mass of solute divided by volume of solution. So it's kind of like density. That's why we have mass of solute. 8 parts per million. This is an extra one. It is, instead of moles, it's mass of solute, and it's divided by the mass of solution. Instead of into 100 like in mass by mass percentage, we multiply by 10 raised to power 6. Parts per million will be used for extremely dilute solutions, and once again this has no unit because they cancel out. Formality, ये basically molality ही है. And what I mean is, instead of moles of solute, it's moles of solute ion upon volume of solution. Its significance, इसका significance क्या है? Okay, we understand कि glass में नमक है. The glass of water must have NaCl, but nahi, NaCl is no longer in the water. Why? Well, NaCl is a strong electrolyte, meaning NaCl very quickly ionizes and forms Na plus and Cl minus ions. NaCl is a ionic bond. So there's Na plus and Cl minus bonded together. In water, this bond breaks and Na plus and Cl minus ions roam separately. Now I put 1 mole of NaCl in water, meaning because one molecule of NaCl has 1 atom of Na and 1 atom of Cl, that means I will have 1 mole of Na and 1 mole of Cl minus each. If I have to find a molarity, that's like I'm trying to find moles of solute, but the solute which is NaCl is not even there, it broke. That means molarity will come out to be 0. But when I find the formality, I'm trying to find the concentration of specific ions. I'll either be trying to find the concentration of Cl minus or concentration of Na. In this case, either way, it's 1 mole each. So in 1 liter, the solution's formality comes out to be 1 formol. In now, the unit is not molar, it is F, meaning formal. If I don't have NaCl and I have another salt like Na2SO4, the problem arises when it dissociates. It will have SO4 2 minus ions. It will have 1 mole of SO4 2 minus ions, but because every molecule has 2 atoms of Na, I will be getting 2 moles of Na plus. I will be getting twice the amount of moles as of SO4 2 minus of Na plus. So if I find the formality, it will be different for Na plus and SO4 2 minus. That's why we cannot use molarity. Na2SO4 is also a strong electrolyte because it's formed from 2 strong acids. It's formed from NaOH and H2SO4. They are strong acids. They combine to form a strong electrolyte which will ionize. Na2SO4 will barely be in the solution. So the formality of Na plus will be 2 formal and the formality of SO4 2 minus will be 1 formal in 1 liter. कहानी खत्म. Relation between concentration terms. Relation between concentration terms. शुरू करते हैं. ज़्यादा कुछ explaining का है नहीं इसमें. You have to learn these formulas, but most of these are from observations and they are not things you can learn from a derivation or a formula. You have to learn these as it is. Strength and molarity. If you look at molarity, it was number of moles upon volume, and strength was mass by volume. If we rewrite number of moles as mass upon molar mass into 1 by volume, mass upon volume is strength. That makes molarity equals strength by molar mass. This molar mass is of course of the solute. So if I had written molar mass of B, it would have been the molar mass of solvent. And I will write AB for solution. Next relation is molarity and density of solution. Density is the total mass upon total volume, meaning mass of solute and solvent upon volume of solute and solvent. Molarity equals to density, which is D, into P. P is the weight by weight percentage of the solute. If you remember, the first concentration term was weight by weight percentage, and that is this P. And all of this into 10. Density of solution. P is the percentage, weight by weight. Third concentration term, molality and mole fraction. Mole fraction. This will be chi of A upon chi of B, meaning ratio of mole fractions into 1000 upon molar mass of B. B meaning solvent. So it's mole fraction of solute by solvent into 1000 by molar mass of solvent. And actually, I will write this here. And mole fraction. The final, last but not least, is molarity, molality, and density of solution. We got all three. This is density of solution, which I also write here. It's equal to molarity into 1 by molality plus molar mass of A, meaning solute, upon 1000. It's still good to point out density is mass of solution upon volume of solution, not just solute. This is density of solution. Okay, so the final topic of this video will be normality. Before we learn about normality, we have to learn a few things like gram equivalents, equivalent mass, and n factor. We will start from n factor and work our way towards normality. To understand n factor, let's take an example of a very common reaction, which is HCl plus NaOH. This is a neutralization reaction, acid plus base. You must have seen this many times. And now I don't care about the products. All I care about is what happens here. The only thing which changes is the electrons. If we look at NaOH was one atom of Na and an atom of O bonded with H. Now O was bonded with H. O itself had 6 electrons and one it's getting from H. So O has 7 electrons. If you remember, atoms need 8 electrons to be stable. That's called an octet. So O needs 1 more electron in order to be stable. Meanwhile, Na has 1 electron in its outermost shell. And Na can either gain 7 electrons or lose 1 electron to become stable. Of course, it wants to lose that electron. So Na is like, okay, you can have my electron. So Na decides to give its electron to O, which results in Na plus and OH having a minus charge. This is an ionic bond. Any ionic compound in a solution of water ionizes. Ionizes meaning it splits and forms Na plus and OH minus. Meaning Na has lost 1 electron, O has gained 1 electron. Now what's happening with HCl? Something similar. HCl, this time it's a covalent bond, and Cl has 1, 2, 3, 4, 5, 6, 7, and it's sharing 1 with H. So Cl already has 8 electrons and H has 2 electrons. But just like how NaOH in a solution breaks into ions. Similarly, HCl will also have its bond break and split. These electrons, both of these electrons, will go to Cl, and so Cl will have minus charge and H will get plus charge. Why did this happen? Why not H minus and Cl plus? ये इसलिए नहीं हुआ क्योंकि firstly Cl has 7 electrons on its own, and so to finish its octet it needs that one extra electron from H. But now H is left as H plus. When H is left as H plus, it has no electrons. It's a lone proton. So how can it be stable? It's very much stable because of a concept called electropositivity and electronegativity. This concept of electronegativity you will learn in future chapters, but the main thing I can tell you from this is H, hydrogen, is a very electropositive element, which means it has no problem giving away its electron. It's fine just being a proton. So when it gives this electron to Cl, it comes out as H plus. And if you remember, anything that gives H plus is called an acid. What happened here? This electron went to Cl, and this electron from Na went to OH. In this process, one electron was transferred. Coming back to n factor is just how many electrons can something transfer. NaOH was formed when Na gave its electron to OH. So a total of 1 electron was transferred in forming this. Therefore, I can say NaOH has an n factor of 1. Similarly, in HCl, what happened? These electrons are with Cl. Cl just took one of the electrons from H, and in doing so, it formed H plus Cl minus. Once again, only 1 electron was transferred, so its n factor will be 1. Okay, let's try another example. In this example, I will have H3PO4, and I want to find the n factor of H3PO4. For this, I will first look at the structure. H3PO4 is a phosphorus atom with a double bond O and 3 bonds with OH, OH, and OH. Now, looking at this, you will think, okay, phosphorus has 3 OH attached to it, so it can break all of these and release 3 OH minus ions, but that does not happen. O is bonded to H. As I said, you will learn electronegativity in upcoming chapters, but what I can tell you from here is that oxygen is what we call electronegative, meaning it likes to take electrons. It's a bully. It likes to take things from other people forcefully. So it will look at H and say, hey, I want electrons. So H, being the nice guy, will give the electrons. The electrons of this bond will move towards O. So it's not actually like this. The bond looks more like this, favored towards oxygen. And since this bond is not symmetric, this bond is weak because H has given its electron almost towards O, which means H has a partial positive charge and O has partial negative charge. It's not a complete positive charge, but partial charge, meaning its electron has displaced towards O. And so when it goes in the solution, this bond will easily break and this will leave as H plus, not OH minus. And H3PO4 can do this 3 times. It has 3 OH bonds, meaning it can release H plus 3 times. So its n factor will be 3. But it gets interesting. I will now, instead of having 3 OH bonds, I have 2 OH bonds and one bonded just H. This is H3PO3. Also an acid, but the difference is now this H is not attached to O. Phosphorus is a weakly electronegative group, meaning it's not so electronegative. It will not take the electrons. This will not happen. And so, if that does not happen, this bond does not become weak, and so this H does not immediately leave. Whereas these H bonds will leave immediately as H plus. And so the end factor of H3PO3 will be 2. It looks like there are 3 H, but only 2 will be leaving. And if I have H3PO2, removing another OH bond and replacing it with H. Now only one H plus will leave, so its end factor is 1. So now the general way of finding end factor was established for 4 things. First is for acids, second is for bases, and third is for salts, and 4 is for ions. Salts are anything which is formed by reacting an acid and a base. Like HCl and NaOH will form NaCl. That's a salt. For acids, end factor is simply number of replaceable H plus ions. Replacing meaning just, for example, in HCl, you can remove H plus and have Cl minus, and something else like maybe Na plus could now replace HCl. It can replace H in HCl. Basically, it's like your relationship status. If you have a girlfriend, she can easily replace you for some other person. So be careful. Cl minus is that girlfriend. It can replace H for something else. And in fact, it will. Na plus will attack it in this reaction. Now, in NaOH, it's a similar game. Now it's number of replaceable OH minus. If you take any base like CaOH whole twice, it has 2 OH minus, and its end factor will be 2. It can give away both of its OH minus. It does not care. Now, BOH whole thrice, its end factor will be 3. But be careful, because BOH whole thrice is not a base. This is just H3BO3. And if I have B in the middle, the structure is like this: B and it has 3 OH. B is not electronegative, so it cannot remove OH. Instead, this OH bond will give away H. So BOH whole 3 is an acid, and it's called boric acid. If I have an ion of Na plus, well, how was it formed? Na plus was formed by Na giving up one of its electrons. Maybe it gave it for someone else, just like you gave your heart for her. So Na gave its electron, Na plus. So how many electrons were displaced? 1. So the end factor will be just the charge, the magnitude of charge. So the ion's end factor is just magnitude of charge, because the magnitude of charge is just a measure of how many electrons were displaced. And if I have something like Na2SO4, now when I have a solution of this in water, it will split because it's an ionic bond into 2 Na plus and SO4 2 minus. Na2SO4 is a salt because it's formed by H2SO4 and NaOH. What's the total positive charge? It's plus 2. How? Na has +1 and there's 2 of them, so +2. SO4 has 2 minus. For salts, N factor is just once again magnitude of charge, but it's magnitude of charge on anion or cation. Cation meaning the element which has positive charge, like Na. Na has +1, but there's 2 of them, so +2. That's the total magnitude of charge. And on anion, SO4 2 minus has once again 2. This is N factor. Why have we studied N factor? Because it will help us in our next adventure, which is called gram equivalents. Some people just call it equivalents, or some call it gram equivalents. It's the same thing. I will once again take the example of a reaction H2SO4 plus NaOH. This now gives me Na2SO4 and H2O. Now if I balance this equation, I will put 2 here and I will put 2 here. That's the equation balanced. And if you see like how many moles of each element we have 1 mole of H2SO4, 2 moles of NaOH, 1 mole of Na2SO4 and 2 moles of water. Moles of every single element are different. Now, in this case it looks simple, but in longer reactions or if you have multiple reactions it will be difficult. Gram equivalence is an idea of something which remains constant in a reaction, something which remains the same for everything. In this, moles are changing. It's 1 mole, 2 mole, 1 mole, 2 mole, but something will be the same for everything in the reaction. Well, if we take number of moles, it's 1 into the N factor of H2SO4. It can give 2H plus, so it's 2. This is now 2. NaOH is, we have 2 moles and N factor is 1. Na2SO4, we have 1 mole. N factor, we just saw, it's 2. And H2O, the N factor is 1 and we have 2 moles. If you happen to see the pattern, everything is now 2. Meaning I have 2 equivalents each of H2SO4, NaOH, Na2SO4 and H2O. So if I found the formula for gram equivalents, it's just moles times N factor. How else can I write moles? Let me just write this. I can write moles as mass by molar mass into N factor. Now what I will do is I will take this molar mass by N factor and I will call it mass by equivalent mass. Because to me it looks nice. Mole is mass by molar mass, equivalent is mass by equivalent mass. It just fits. So equivalent mass is now the mass of one equivalent of something. So equivalent mass is mass of one equivalent. Meaning it's this, I can write it molar mass by N factor equivalent mass. And if you remember our formula for molarity was mole by volume. Now मैं चुपचाप से मोल को हटाऊं और मैं लिख दूं equivalents मैंने मोल की जगह इक्विवेलेंस लगाए और m की जगह मैंने n लगा दिया। गुस्सा होगे? हाँ सर होंगे, मत हो। यही है नॉर्मेलिटी। दिस इज नॉर्मेलिटी। It's just gram equivalence by volume. So what I derived from this is, firstly, normality is a concentration term which is treated like molarity. Instead of moles by volume, it is gram equivalents by volume. Gram equivalents is a term we invented. It's a type of mole we invented which remains same throughout a reaction, and we write this as just the mass by equivalent mass. And the equivalent mass is just the molar mass upon the conversion term, which is n factor. And this gram equivalent we can rewrite as moles into n factor. Now if you remember molarity is just moles per volume. So if I just take the formula for normality and I just replace this by moles by volume into n factor, it's the same thing, but now this thing becomes molarity. And normality then therefore becomes molarity into n factor. So I have two solutions, and I know this solution is 0.5 molar and this one is 0.1 molar. I know that this one has a 1 liter n factor, this one has an n factor of 2, this has an n factor of 1. I want to find how much of this solution I have. I want to find out the volume of this, so I call this V. If these two things are reacting, their equivalents must be same. They must have equal number of equivalents to react fully, and if they are reacting fully, I can just use the formula of gram equivalents and just equate them for both. Now I don't know the masses, I don't know the equivalent masses, but I know molarity, n factor, and this one's volume. So I can just write this as normality, which is n into volume of the first element of the first solution, and is equals to the n2 v2, meaning normality into volume of the second solution. The first solution is 0.5 into 2 because molarity is 0.5 and n factor is 2 into volume, which is 1 liter, and the second solution has a normality of 0.1 times 1, which is 0.1 into V, and the V I have to find. I can write 0.1 as 1 by 10, 0.5 into 2 is 1, and so this just becomes 1, and so the volume of this becomes 10 liters, meaning I need 10 liters of the solution for it to react completely with this solution. So in the next video I will be having questions from exams like JEE Mains and JEE Advanced, and in that video I will be using all of these formulas, and maybe if we have some question which we don't know, I will introduce new formulas. So please stay tuned for the next video, and I hope you learned something from this. Please give me feedback in the comments. Until then, good morning.